The Contingent Preamp is a recent work in progress, and I'll talk about its background and some initial findings. In my practice, I focus upon creating feedback paths through objects, surfaces and materials using contact microphones coupled with small vibration speakers. Manipulation of, for example, position and pressure of such transducers is used to interrogate improvised music's materiality through entanglement of human and material in performance. Working with DIY contact microphones, impedance mismatch may result in a tinny and harsh sound, which potentially curtails the frequency range of a surface. Preamplifiers are a possible remedy. They also introduce additional gain, and in a feedback system, I hope this might enrich performance practice under the somewhat nebulous term of liveliness. Loosely, I'm looking to easily drive a system's feedback, the availability of responsive performance dynamics, and instability so that the system might play itself. Such liveliness is suggestive of agentic and co-creative properties of circuits and materials, and is somewhat akin to Jane Bennett's vitality, the capacity of things to act as quasi-agents or forces with trajectories, propensities, or tendencies of their own. I set about building a range of preamplifier circuits, and one subset of these investigations was based upon junction field effect transistors, or JFETs. There were several of these circuits, all using different types of JFETs and various other component values, but I noticed a common pattern in circuit design. I have since discovered this topology is known as a common source amplifier. When building, I also improvised and experimented with component substitutions just to see what would happen. These experiments generally worked, albeit probably less than ideally, and this topology seemed quite resilient. JFETs are renowned for inconsistent manufacturing tolerances, and several schematics suggested measuring and discarding those that fell too wide of the circuit design. Peter Blasser's synth designs embrace such component tolerances. In his Rollser, the multiple dimensions of capacitor specification work together to cause individuation. I therefore took wide JFET tolerances and circuit topology resilience as invitations to design something open to variability, improvisation and contingency. Peter Blasser's work also offers what he calls hairy capacitors, and these denote a space open to a wide range of component values. He gives suggested ranges, but rather than a circuit schematic with specified values, he instead presents a circuit layout with more mutable symbols. So I designed an open JFET-based preamp circuit layout which can accommodate the various schematics I've been investigating, but also allows for substitution and experimentation. Rather than prescriptive values, I provide suggested recipes and information to allow you to do your own experiments, and that is the Contingent Preamp. So far, I've built 20 of these, populated quite randomly with components to hand. 5 didn't work at all, and only 7 had any sense of liveliness. I'm therefore having to rethink the resilience I previously experienced and how this framework can encourage experimentation whilst reducing, though not eliminating, the risk of failure. I set about testing these lively circuits, and for simplicity and some unresolved issues with driving vibration speakers, I only used them with a miniature guitar amplifier. I fixed a contact mic to a single spot and tested each preamp at a range of settings to note any differences and interesting phenomena. Towards the end of the first set of experiments, I realised some strange audio effects were the result of a drained battery. In the second set of experiments, I realised there was a problem with the soldering on one of the circuits. For the third round, some of the circuits produced nice, slow undulations and seemed promising. However, the contact microphone I used has been backed with an epoxy resin. I do this to provide durability and to attenuate self-resonance. Here though, it dampened performance. A fourth set of tests used a raw piezo disc in the same spot, and whilst there were still some interesting moments, they often quickly descended into undifferentiated noise. I'm reminded here of Tim Ingold's observation when describing the animating forces of a flying kite which suddenly leaped into action, twirling, spinning, nosediving and flying. He asks, had some animating force magically jumped into the kites, causing them to act most often in ways we did not intend? Replying, of course not. It was rather that the kites themselves were now immersed in the currents of the wind. The kite that had lain lifeless on the table indoors had become a kite in the air. Similarly, my preamplifier circuit is always in the world and co-constructed by its relationship to drain batteries, bad soldering, guitar amplifier electronics, piezo properties, component manufacturing tolerances, etc. The liveliness I am looking for is equally co-constructed through performance. For further tests I interacted, albeit minimally, and here I found more interesting sounds and phenomena, lively moments where the assemblage would take on musical trills, twists and turns. I moved this work to a practice space where I could let things go on for longer and louder. I'm still assessing the audio recordings and video footage, but here I found numerous moments of creativity, playability, liveliness and difference. In particular, two circuits stand out. Firstly, these were the only two which wouldn't feedback by themselves. They required some interaction to work. They also didn't react to interaction in a typical way. There is generally a clear relationship between an action and a sonic response, but with these two circuits things seem especially non-linear. Sometimes it would react to the gentlest touch, at others no amounts of coaxing would produce sound at all. Heavier physical interaction would seem to elicit some response before eluding me again. And one of these circuits seemed particularly resistive. It was a constant battle to get anything from it. The other seemed resistive at first, but I discovered that if I constantly varied pressure, it would continue to work, still with an inherent non-linearity, but it could be coaxed into performing with me. I hope to find, through performance, evidence of agency in the circuits, materials and objects I had assembled. I mostly expected to find this in various self-playing behaviours whereby feedback systems would enter into self-determined variation and musicality. More telling have been moments of interaction. Whilst the two non-linear examples seem to require a human collaborator, their unpredictability, resistances and need for constant attention has made their agentic qualities more accessible to me. In Bennett's terms, it is here I encounter a creative materiality with incipient tendencies and propensities which are variably enacted depending on the other forces, affects or bodies with which they come into close contact. Finally, I'm in the process of rewriting and redesigning a printable circuit and instructions for these contingent preamps. I'm also assessing the audio recordings and video footage I have assembled. In the meantime, I speculatively layered all of the audio recordings and played them simultaneously. What struck me here is that the total excess and exuberance of 7 feedback circuits all squealing simultaneously seems more suggestive of the liveliness inherent in these systems than any one recording alone. It simply isn't possible to track any notion of my performances through this cacophony, and by obliterating these traces we're left with an overwhelming sense of material flows and forces. I'll leave a little of this to play us out.